Okay, so today we're going to talk about some additional security technology, intrusion detection and prevention systems, and a couple of other security tools like port scanners and so forth. Here's the learning objectives. Going through this PowerPoint, about 60 slides, you should be able to identify and describe the categories and operating modules of intrusion detection and prevention systems, define and describe what honeypots, honey nets, and padded cell systems are, define major categories of scanning and analysis tools, and then describe the specific tool used within each category, and then some various methods of access control, including things like biometric mechanisms. Quick introduction. We want to again emphasize that the protection of organization assets depends on people as much as technical controls. Technical solutions guided by policy, properly implemented, are essential to information security programs, and then advanced technologies like intrusion detection systems and prevention systems can be used to enhance security of information assets. As we go through this in intrusion and talk about it a little bit, we need to make sure that we understand some definitions, and a couple of important ones here is intrusion and intrusion prevention. So an intrusion is a type of attack on information assets in which the instigator attempts to gain entry into a system or disrupt the normal operations of a system with almost always the intent to do malicious harm. Incident response is the identification of and classification of, response to, and recovery from an incident, and is frequently discussed in terms of prevention, detection, reaction, and correction, cyclical process for incident response. Intrusion prevention consists of activities that seek to deter an intrusion from occurring. Intrusion detection consists of procedures and systems that are created and operated to detect system intrusions. Intrusion reaction usually encompasses the actions that any organization would undertake when an intrusion event has occurred. It's again a well-documented process. Intrusion correction actions and activities really are designed to finalize the restoration of operations back to a normal state, and hopefully includes seeking to identify the source and method of the intrusion to ensure that the same type of attack cannot occur again, and then they return to intrusion prevention and basically close the loop on the incident response. Intrusion detection and prevention systems, they're really designed to detect a violation of its configuration and activate some sort of an alarm. System administrators can choose from a variety of different configurations of the various alerts and the associated alarm levels for each type of an alert. No two organizations are going to do this the same. Many intrusion detection systems enable administrators to configure the system to notify them directly of trouble, maybe via email or page or text message. The system can also be configured to notify an external security service of a potential break-in, so it can be outsourced as well. Some basic terminology that you should be aware of, and I think that you're going to find many of these in the reading, so I just threw them up here. I'm not going to go through each individual one, but you should be aware of what they are, and if not, you can go out and find them in your textbook. Why do organizations use intrusion detection systems? Well, I think that a lot of organizations use it to prevent problem behavior by increasing the perceived risk of discovery and punishment, much the way in the physical security world that closed circuit television is used as a means to increase the perceived risk of being caught. Also, to detect attacks and other security violations, to deal with early warning systems to alert an organization that an attack is imminent, document existing threats, to act as a quality control for security design and administration, especially in organizations that have very large and complex networks. Intrusion detection systems can really go a long way towards helping verify rule sets such as firewall rule sets and and ACLs are working appropriately, and then to provide information about intrusions that take place, which allows for us to do that closing the loop with the diagnosis, recovery, and correction of faulty security mechanisms. A bunch of different types of intrusion detection prevention systems that we want to talk about. They operate in really three basic ways. They're either a network-based, a host-based, or an application-based systems. A network-based intrusion detection system is focused on protecting those network assets. Okay. A host-based version is focused on protecting a particular server and the information that sits on that server or is hosted on that server. And then application-based models work on one or more host systems and that may support a single application orientated to defend that specific application from specific forms of attack. So those are the three basic kinds that we'll talk about. Here's an example of an intrusion detection system and prevention system that's both a host-based and a network-based, and you can see again basic network design. You have untrusted network, you have your border router, your external router, and then this depicts a network intrusion detection prevention system, which is really looking at the data packets that flow across the network and maybe alerts the security control center of some unusual patterns. And then this also depicts a host-based intrusion detection system, which is really looking at the data usage on a particular system, and it's really using things that we commonly associate with change management, access, executions, saves, deletions, those types of things to notify an organization that there may be some issue on that particular host. And we'll get into the strengths and weaknesses of both as we move forward. So network-based intrusion detection systems, again, they can reside on a computer or appliance connected to a particular segment of an organization's network. They monitor network traffic on that network segment only, and they look for indications of ongoing or successful attacks. When a situation occurs that the network-based intrusion detection system is programmed to recognize and as an attack, it will respond by sending some sort of notification to the administrator. When network-based intrusion detection systems are examining packets that are transmitted through the network, they look for attack patterns within the traffic, like large collections of related items that are of a certain type, which would indicate that perhaps a denial of service attack is underway, or the exchange of a series of related packets in a certain pattern, which could indicate that perhaps there's a port scan or something like that going on. And when we talk about this, and I think I have some slides coming up here, network-based intrusion detection systems work in a couple of different ways. And one way that they work is it's a signature-based, very much like what you see in your antivirus. A denial of service attack looks like a denial of service attack, and if you're using a signature-based network-based intrusion detection system, it's just comparing network traffic packets against known types of attacks. NIDs are usually installed in specific places on the network, and there's some best practices that we'll get into about where we should see this. But basically, you want to put them where it's possible to watch traffic going into and out of a particular network segment that you can consider important or sensitive. They can be deployed in a variety of different areas to watch specific grouping of host computers or a specific network segment, or it could be installed to monitor traffic between systems that maybe make up an entire network. Really, you're only limited on your ability to determine what you think is the most sensitive areas. Again, I mentioned a little bit ago that they basically work in two ways: signature matching, and here, in order for them to determine whether or not an attack has occurred or may be underway, they look for attack patterns by comparing current activity to known signatures in their knowledge base. And this is the exact same way that antivirus works. Basically, they compare captured network traffic to using a special implementation of the TCP/IP stack that reassembles the packet and applies protocol stack or application protocol verification. And this is the process of looking for invalid data packets. And The application protocol verification uses a higher order protocols to examine for unexpected packet behavior or improper use, and basically they're just looking to match it to known types of attacks. Some advantages of a network-based intrusion detection system is a good network design and placement of the NIDs can enable an organization to use very few devices to monitor a large network. They are usually passive and can be deployed into existing networks with little or no disruption to normal networking operations. In other words, they don't require a lot of resource overhead because they're not doing much. They do have to report back generally to a central management or some sort of management device, so they will create some network traffic, but it's usually fairly minimal. And because they're passive, they're not usually directly attacked, and many times they're not even able to be detected by an attacker. So that's a really important positive. Some disadvantages, of a network-based intrusion detection system or the sensors is that high volume can overwhelm it, and if they become overwhelmed, they obviously can't look at all the packets, which means they have the opportunity or the potential to miss an attack that might otherwise have been recognized. In order to be effective, again, they have to look at all the traffic. They cannot analyze encrypted packets, making some network traffic invisible to the process, and it's relatively unusual to find networks internal traffic on a network encrypted anyway, so that might be a good indication that you have a problem if you're have a lot of encrypted traffic flowing across your network. A network-based intrusion detection system might not necessarily be the best solution. A signature-based network intrusion detection system might not be the best solution. And then some forms of attacks are not easily caught by NIDs, specifically if they're using or involve fragmented packets, and slow attacks are very difficult for NIDs to catch doing a typical analysis. There's a couple of other types of NIDs that we should talk about, and one of them being wireless, and here these are specifically designed to monitor and analyze wireless network traffic and any issues that are associated with physical security, since like sensor range and access points and wire switch and wired network connections can impact the effectiveness of a wireless network-based intrusion detection system. Another way that NIDs work is through network behavior analysis or anomaly-based, and here they're examining network traffic in order to identify problems related to traffic flow. These things like denial of service attacks and scannings and worms, unexpected application services, and policy violations can be picked up by network behavior analysis systems. The second type of intrusion detection system that we want to mention briefly are host-based intrusion detection systems, and these systems reside on a particular computer or server referred to as a host, and they monitor the activity only on that system. They are also sometimes referred to as system integrity verifiers because they benchmark and monitor the status of key files on that system and detect when an intruder creates or modifies or deletes these monitored files. Most host-based intrusion detection systems work on the concept or the principle of configuration or change management, which means they record the sizes and locations and other attributes of system files and trigger alerts when one of the following changes occurs. For instance, a file attribute changes, or a new file is created, or an existing file is deleted. They have the advantage to a NID over, or I'm sorry, a host-based intrusion detection system over a network-based intrusion detection system is that they can be installed in a way that it can access information that's encrypted when it's traveling over the network, which means an attack that's encrypted can be detected by a host-based intrusion detection system. Because they rely on the classification of files into various categories and then apply that change notification action. Depending on the rules of the HIDS configuration, they can monitor multiple computers simultaneously by creating configuration files on each of the monitored hosts and making each HID report back to that master control console, which is usually located in the system administrator. So they can be a very robust tool. The disadvantage is that they can only see local events on that host system, and anything that occurs on the network they're not going to see because they're only looking at that one particular host. So there's no ability to aggregate information across the network by a host-based intrusion detection system. HIDs function on because they're on the host system. Again, I mentioned they do have the opportunity to see what, where encrypted traffic has been decrypted and it's available for processing. They can detect attacks that are initially encrypted because the modern, or I'm sorry, switch network protocols do not affect HIDs, and they can also detect inconsistencies in how applications and systems programs are used by examining the records stored in audit logs. So again, it's basically designed to work on as a change management system. Some disadvantages: they have to be configured and monitored for each individual host, so there's a management issue. They are vulnerable to direct attack and attacks to the host operating system. If they're not appropriately optimized to detect multiple scanning, nor is it able to detect scanning of non-host network devices like switches and routers. They are susceptible to some types of denial of service, and they do tend to use a lot of resources, in particular disk space, to retain the host operating system audit logs. HIDs can use large amounts of space to retain the operating system's audit logs, and to function properly it may require a large amount of disk capacity to be added to the system. And obviously they do have a performance issue where they can add overhead to the host system. In some cases they may actually reduce the system performance below acceptable levels. As I had mentioned earlier, intrusion detection systems work in a couple of different ways, and one of them is a signature-based. And if you think about signature-based, really you should fall back to the concept of the antivirus or your antivirus software, where they're examining data traffic for search of patterns that match known signatures. They're pre-configured, predetermined attack patterns. Signature-based intrusion detection technology is widely used because many attacks have clear and distinct signatures, so they're readily or easily detected. The problem with this approach is that it's going to miss the new attack strategies that have not been identified, that have not had a signature identified, and have not been updated in the database of the network intrusion detection system. So that is something that we have to take into consideration when you're choosing the type of detection method that you're going to use. And the other type is that I mentioned was the statistical anomaly-based intrusion detection preventer system. And here it's more of a behavior-based system which periodically samples network activity, and using statistical modeling compares the sampled network activity to traffic that is known to be normal. It has to establish some sort of performance baseline and then randomly samples network traffic against that baseline to determine if it's what would be considered normal. If the measured activity is outside the baseline perimeter, and this is sometimes referred to as the clipping level, the intrusion detection system will trigger an alert notifying the administrator, who then should begin the incident response process. The data that's measured from the normal traffic and is used to prepare the baseline can include variables like host memory or CPU usage, network package types, and packet quantities. Now, the advantage of this statistical anomaly-based approach is that it can detect new attacks because it's looking for abnormal activity of any type, not necessarily abnormal activity just associated with an attack. Unfortunately, they require a lot of overhead and processing capacity than your signature-based network-based intrusion detection system, and they must constantly compare patterns of activity against the baseline. And another drawback is that these systems may not detect minor changes to systems and may generate some false positives. Another detection method that should be mentioned is the stateful protocol analysis. Here, again, comparing predetermined profiles of definitions of benign activity for each protocol state against observed events for identifying any deviations. So it is, using predetermined profiles like signatures, and then looking for any deviation from that activity, from that activity. They store and use relevant data detected in a session to identify intrusions involving multiple requests and responses. This allows the intrusion detection system to better detect specialized or multi-session attacks. The drawback here is very complex. Lots of processing overhead. They may fail to detect some protocol violates fundamental, unless the protocol violates some fundamental behavior, and they may cause problems with the protocol that it is examining. Log file monitors are similar to network intrusion detection prevention systems in that they, are really looking at and reviewing the log files generated by servers and network devices, and even other intrusion detection systems for patterns and signatures in the log files that may indicate that an attack or an intrusion is in the process or has already succeeded. The pattern that signifies an attack can be subtle. It can be hard to distinguish when one system is examined in isolation, but it may be easier to identify when the entire network and its systems are viewed holistically. Of course, this approach requires the allocation of a considerable amount of resources, since it will involve the collection, movement, storage, and analysis of large quantities of data. Once the intrusion detection system identifies some sort of anomalous network situation, it does have a number of options depending on the policy and the objectives of the organization that has configured it, as well as the capabilities of the organization system. The responses can be classified as active or passive. An active response is one that's in which a definition or a definitive action is initiated when certain types of alerts are triggered. Passive response options simply report the information that they have collected and wait for the administrator to take action. And they can come in a variety of different ways: audible alarms, visual alarms, traps and plugins, email messages, pages and phone messages, log entries, packet dumps, evidentiary packet dumps, which is handy if you're going to do a post-mortem. They can take action against the intruder by dropping the connection. They can reconfigure the firewall. You can have them terminate the session or terminate the connection. So there's a variety of different things depending on the configuration of the system itself. So when an organization goes through the process of selecting an intrusion detection prevention system, there's a wide array of products available today, and that address a broad range of organization securities and considerations. And given that range of products and features, the process of selecting a product that represents the best fit for your organization is going to be challenging. There are a bunch of different ways about going about choosing it, and questions that may be useful when preparing a specification for acquiring and deploying an intrusion detection product are things like, what are the requirements that are levied from outside organizations? In other words, are you somehow regulated by industry that perhaps has some specific requirements as far as intrusion detection systems? And then, I think to me more importantly is what are your organization's resource constraints? Because you have to buy this. There's a life cycle of support for intrusion detection systems. You have to be able to support it once it's up and running. Do you have the appropriate amount of staff? Are your staff appropriately trained in order to do this? And then, what is your legal authority, or do you have a policy in place to instigate changes based on the following findings of your intrusion detection system? In other words, how much reliance are you going to place on these tools to determine whether firewall rules need to be changed or an investigation needs to be instigated? So there's a lot of thought and a lot of different types of questions that need to be asked and answered before you go out and install or purchase and install or develop and install an intrusion detection system. Some basic product features and quality things that you should be aware of. When you're choosing one is scalability. You want to make sure that the device or the package that you're buying is able to expand and shrink with your organization. Has it been tested? Right? Has the product been tested against functional requirements? Has it been tested against attacks? And you should be able to ask the vendor, and they should be able to provide you details for security testing in which the product has been subjected to. What is the user level of expertise? Right? Do I need to send somebody to training? Am I going to have to get them some certification? Is the product designed to evolve as the organization grows? And then, what are the support provisions for the product? Product installation, configuration support, ongoing product support, signature updates if it's a signature based, how often and what's the cost of the subscription, how quickly after a new attack is made public will the vendor send out a new signature, software updates included, technical support services included. There's a lot of things that you want to be aware of before you go out and purchase one of these devices and implement it, and then find yourself stuck when you run out of support that you can't provide with the resources within your organization. Like any security tool, there are strengths and limitations of these tools that we have to be aware of. One of them being some of the strengths and some of the things that they're very good at is they can monitor and analyze system events and user behavior. They can do a great job at testing your state of system configuration, your security system configuration. They're great for baselining. They can recognize system events and match them against known attacks, and they can recognize activity patterns that vary from normal. So these are the things that they're good at. They also manage operating system audits and logging mechanisms and the data that's generated. They are great at alerting staff when attacks are detected, measuring enforcement of security policies, providing default information on security policies, and then they also allow for the novice or the non-security expert to perform important security monitoring functions as well. Some of the weaknesses that they cannot do is they cannot compensate for weak or missing security mechanisms. They cannot instantaneously detect and report when network traffic is heavy. Remember, some of these network-based intrusion detection systems do not respond well when they're being overwhelmed by traffic. They have a hard time detecting new attacks and variants of existing attacks, that zero-day issue. If the attacker is sophisticated, they're going to have a hard time effectively responding to attacks, and then they cannot do any investigation without human intervention. So this is not the end-all, be-all. They also, have trouble resisting attacks intended to defeat or circumvent them. They have trouble compensating for problems with fidelity of data sources, and then dealing effectively with switched networks as a whole. So there's three basic control strategies for implementing an intrusion detection system. Centralized, where all the control functions are implemented and managed in a central location. A fully distributed, where the control functions are applied at the physical locations of each component, and then partially distributed, which combines the two. The individual agents can still analyze and respond to local threats, but they report to a central facility to enable the organization to aggregate that information across the facility. Here's a graphical depiction of a centralized intrusion detection system, and you can see that there's a council, right, an intrusion detection management council, which collects all the information from the variety of sources. Here's fully distributed, where each individual sensor is dealing with its own network segment. There's no aggregating of information. And then the partially distributed, where we still have an enterprise intrusion detection system, and then we have subnet intrusion detection system councils, which handle issues within its own network segment, but still roll information up to the main council so that it can be aggregated across the organization. Again, talking about this deployment, like the decisions regarding control strategies, the decision about where to locate the individual components of an intrusion detection system can be as much a science as it is an art, or as much an art as it is a science. An organization can select an intrusion detection system, prepare for implementation. Planners have to select a deployment strategy that is based on a careful analysis of an organization's security requirements and integrates it within the organization's existing information technology infrastructure. But at the same time, they have to try to cause minimal impact on the performance of the infrastructure. You can use both network-based and host-based systems in tandem to cover both individual systems that connect to an organization's network and the network itself. Some basic locations where you would expect to see, at a minimum, network-based intrusion detection system sensors behind each external firewall and in the network's DMZ. Intrusion detection systems see attacks that originate from outside the world, and they may penetrate the network defenses. These sensors placed in the first location there behind the external firewall and in the DMZ will identify problems with the network firewall policy or performance, and they also will see attacks that might target web servers or FTP servers, both of which commonly reside in the DMZ. We would want to put a sensor outside the external firewall to really document the number of attacks that originate on the internet that target the network, and to document the types of attacks that are originating on the internet that target the network. On location 3, major network backbones, we would want to put them in a spot where they can monitor large amounts of network traffic, increasing the chances of identifying or spotting an attack. And it also here detects unauthorized activity by our organizational employees, by authorized users within the organization. So that gives us the opportunity to use a sensor to monitor both network traffic from external sources as well as internal sources. And then location 4 on critical subnets, again, detects attacks targeting specific systems and resources. And again, it also allows organizations with limited resources to focus those resources on network assets that they consider the greatest value. And then graphical representation of those 4 key locations, right? Just inside the organization's firewall, outside the organization's firewall, major backbones, and then sensitive networks. When we look at deploying host-based intrusion detection systems, the proper implementation can be difficult and time-consuming, and each HID must be configured to its host system. Deployment begins with implementing the most critical systems first. Remember, these are resource-intensive devices that we're going to be putting on systems, so we have to take that into consideration. Installation will continue until either we have all the systems are installed or the organization reaches that planned degree of coverage that it's willing to live with in regard to the number of systems and the percentage of network traffic. Just as technicians can install HIDs in offline systems to develop expertise and identify potential problems, users and managers can gain expertise and understanding of the operation of HIDs by using a test facility. And I would recommend that if you're going to use a HID, the first thing that you want to do is create a test facility to see how it's going to impact your hosts before you throw it into production and then crash a host or render it unable to provide the services that you need it to, and then you've got yourself a bigger problem. So how do we measure the effectiveness of intrusion detection systems. Four basic ways that we can look at it. The two dominant metrics are evaluate the number of attacks detected in a known collection of probes, and then we can examine the level of use, commonly measured in megabytes per second of network traffic at which the intrusion detection system fails. In other words, we stress test it. An evaluation of an intrusion detection system might read something like this. At 100 megabytes per second, the intrusion detection system was able to detect 97% of directed attacks. Since developing this collection can be tedious, most vendors provide testing mechanisms that will allow you to verify system performance as expected. Again, against an individual system. So if we move on to these security controls referred to as honeypots and honey-nets and padded cells, will give you the definitions there, and you can read them. I'm not going to read them out to you, but I want to make sure that you're aware of really, basically what they are is decoy systems or decoy collection of systems that are put out there to specifically to be attacked. And the honey nets and honey pots are created for a variety of reasons. One reason is research. If you want to understand the most current attack methodologies and the most current attack tools that are being used, you put a honey net out there or a honey pot and allow it to be attacked. It also can be used to give the attacker something other to attack rather than your network. You make the honey pot or the honey net look attractive enough to move them away from the actual network. You're going to, in essence, lure them away. Padded cells are honey nets that's been protected so it cannot be easily compromised. So it's basically a honey net that's been hardened to a point that it can be attacked, but it's not as easily attacked. They often operate in tandem or in connection with an intrusion detection system, and then basically the way it works is when the intrusion detection system detects an attack, it transfers the attacker to a simulated environment where they can really cause no harm, and allows the organization the opportunity to respond in a meaningful and effective way. Some advantages, are clearly if we can distract an attacker to a network that has meaningless and useless information to it, and that's all the better for us. It also gives the organization an opportunity to figure out how it wants to respond, as well as, and I had mentioned, we can monitor and record the activity that the attacker is doing, which helps us prove motive if we need to have law enforcement brought in. And it also gives us the ability to improve our system protections as well. These are also used to try to identify malicious insiders that may be snooping around the network. So there are some real advantages to honeypots and honey nets and so forth. Again, there's some disadvantages, one of them being legal implications. Some view this type of activity as entrapment. It's not a view that's shared by myself, but that is something that you should be aware of, and that the legal department might very well be interested in having a discussion about. You also have to be concerned that, if you move a hacker into this or an attacker into a padded cell and they recognize what it is, and then they're either able to compromise the system and then use it to launch a more hostile attack, or you put them in a position of some sort of retribution where they come back with a more rigorous attack on your network. So you have to be aware of these things, and not to say the least, your administrators and your security managers need to be well versed in in this technology in order to use it. It's not something that you would just want to get into if you don't have some real expertise in it. So I want to talk a little bit about some scanning and analysis tools, and really these are typically used as part of an attack protocol to collect information about an organization or a target that the attacker would need to use in order to launch a successful attack. Attack protocol is a series of steps and processes that the attacker is going to use in a logical sequence to launch the attack against the target, and we as security professionals would want to understand how this is done. We would want to use the same tools that an attacker would, so that we can see how our network would respond to it. Some additional concepts that are often referenced in scanning and analysis is this concept of fingerprinting, which is really the second phase of an attack. And again, it's intelligence and data gathering process, systematic survey of the organization, internet addresses collected during that initial phase to see what services are offered by the host, reveals information about internal structure, operation, nature of the target system, network or the network for anticipated attacks. There's a lot of tools that were created to find vulnerabilities in system tools and networks, and they are valuable for the network defender, for the network professional, but they can also quickly pinpoint parts of the system that need to prompt repair and close the vulnerability. And attackers use these very same tools to do the same type of reconnaissance that we would expect to see. So port scanners, port scanning utilities are tools that both attackers and defenders use to identify or fingerprint the computers that are on an active network, as well as ports and services active on those computers, the function and the role of the machines are fulfilling, and a bunch of other useful information that can be determined, like protocols and resources. And it goes without saying that the more specific the scanner is, the better the scanner is, the better the information it's going to give both the attacker and defender, and therefore you will want to make sure that you're using the best quality tool that you can. Some commonly used ports that you should be scanning for and seeing if they're available. Some of them are inherently vulnerable, and if you're finding them, you should probably take steps to turn them off. Some firewall analysis tools that you can go out and use that automate remote discovery of firewall rules and can really assist the administrator in analyzing the rules to determine exactly what they allow and what they reject. Incidentally, administrators who feel wary of using the same tools of hackers should remember that regardless of the nature of the tool that's used to validate or analyze a rule configuration, it's the intent of the user. Right? It's the intent of the user that will dictate how the information gathered is used. In order to defend a computer or a network, you have to understand the ways it can be attacked, which means you have to use the tools, the same tools that an attacker is going to use, and take that information and view it from that perspective of an attacker. A tool that can help close up or open a poorly configured firewall will help a defender, a network administrator or a network security officer minimize the risk for attack. So, you have to kind of get past that. Oh, I don't want to use that. It's not a, it's not a well tested or it's not a well viewed tool. If it's a tool that an attacker is going to use, you had better be familiar with it, and you better be familiar with the information that it can use or can find. So, we want to. One of the things that's important for completing a successful attack against the system is you have to be able to detect or determine the target's operating system. Very valuable information to attacker, because once that's known, all of the vulnerabilities that are susceptible to can easily be determined. There's a bunch of tools out there that use network protocols to determine remote computer operating systems. Most operating systems have a unique way of responding to ICMP requests. These tools are reliable at finding matches and thus detecting the operating system of remote computers. System administrators and network administrators should be aware of this and take plans and put plans to restrict the use of ICMP through their organization's firewall when possible, and then within the internal network as well, if at all possible. Vulnerability scanners. An active vulnerability scanner is one that initiates traffic on the network in order to determine security holes. As a class, or as a set of tools, this type of scanner identifies as exposed user names and groups, shows open network shares, exposes configuration problems and other vulnerabilities in servers. A passive scanner is one that listens in on the network and determines vulnerable versions of both server and client software. These tools are really simple monitoring of the network connections to and from the server to gain a list of valuable operations or vulnerable applications. Further, more passive vulnerability scanners have the ability to find client-side vulnerabilities typically not found in active scanners. The next tool that we want to talk about are packet sniffers, and to me, I think these are one of the greatest tools available. And if you want to start to become proficient with the tool, or if you haven't had the opportunity to become proficient with a packet sniffer, this is a great place to start. And they really are, well, sometimes referred to as protocol analyzers or network protocol analyzers. And basically, it's a tool that collects copies of all the packets from a network and analyzes them. It can provide you with a valuable information for diagnosing and resolving network issues, but used in a malicious manner, great tool for eavesdropping on network traffic. Typically, to use these types of programs most effectively, the user has to be connected to or should be connected to a network from a central location. To use a packet sniffer legally, an administrator should obviously be on the network that the organization owns, make sure that they have direct authorization of the owners of the network, and that should go without saying, but I'm going to reiterate it here. Whenever you're going to do an analysis of your network, you want to make sure that you have proper authorization to do this. Scanning networks and using things like packet sniffers, because they can reveal sensitive information, you want to make sure that you have written authorization by your supervisor or by management before you launch one of these things. I can only think of one case where an administrator from a retail organization decided on his own that he was going to employ a packet sniffer on the network to determine to do some analysis, and ended up losing his job over it because he didn't have proper authorization and he was collecting customer information, which is not something that the organization wanted him to do. And then, make sure you have knowledge and consent of the content creators before you go ahead and launch that. Probably one of the most popular ones out there is Wireshark, and it's actually a great tool. There's some really great tutorials out on like YouTube if you want to learn how to use it. Fantastic tool to become proficient at. And then there's some wireless security tools. Security professionals have to assess the risk of wireless networks. You should include the ability to, or your toolkit or your skill set should have the ability to appropriately sniff wireless traffic, scan wireless hosts, assess level of privacy and confidentiality, identify network access points, wireless access points, so that you can look for rogue access points. So you want to make sure that you have a good understanding of how those tools work as well. Moving into biometric access control, based on, and most of us are familiar with it, right? It's using some sort of measurable human characteristic to recognize an individual as being authorized or to determine an individual is not authorized. Things like fingerprint comparison, palm print, hand geometry, facial recognition, retina pattern, iris pattern. There's a bunch of different ones that are available. Little graphical representation. Signature recognition is included in here, whether you believe it or not, or buy into it. It's sometimes considered a biometric measurement. A couple of things that we have to be concerned about when we talk about biometrics and the effectiveness is false reject rate, or the rejection of legitimate users, and then the acceptance of unknown users, or false acceptance rate, and then this crossover error rate, the point where false reject and false accept rates cross when graphed. This is the most common important overall measurement of accuracy of biometric systems. So we want to make sure that when we implement technology like biometrics, because of its cost, we want to make sure that we're getting the best bang for our buck here, and you want to be aware of those three rates, right? The false reject rate, the false accept rate, and then the crossover error rate are three of the most important measurements. And obviously, there's still some issues with how widely accepted biometrics is. How willing are the users to participate in this particular type of access control and authorization. Some are more accepted than others. Obviously fingerprints are readily acceptable. They're not considered too intrusive. Nice graphical representation here of the basic types of biometrics: face, fingerprint, hand geometry, keystrokes, hand vein, iris, retina, signature, voice, facial recognition, and DNA. How universally accepted they are, how unique or how accurate they are, performance, collectability, performance, acceptability, and so forth. These are things that you want to take into consideration, and you may want to actually get the input from your users before you go out and invest a lot of money on it. Probably the most common out now is fingerprint. You still have some face. You still have some organizations implementing things like facial recognition and iris and retina. There's some drawbacks. Things like voice have some issues. Again, do your research before you make the investment in the biometric controls. Basic summary: intrusion detection systems can detect violations of configurations. They have the ability to alert. Network-based versus host-based intrusion detection systems, the strengths and weaknesses of both. You want to make sure you choose the product that best fits the organization's needs. Honeypots are designed to be decoy systems. Two basic variations are honey nets and padded cells. Scanning and analysis tools are used to pinpoint vulnerable systems, holes in security components. They can be used for good or evil. And then authentication is validation of prospective users' identity. So that pretty much wraps up where I wanted to get to you as far as intrusion detection systems and some other security technologies. And thanks.